2:14. Thank you. I was going to ask that. I'm glad you said something. All right. Yeah, Wednesday. I didn't remember it before the break, what time on Wednesdays, and I definitely don't remember now. All right. Well, here we go. Let's do some of this. We're going to do a couple real basic things first, and then we'll get into the addition and subtraction. All right? Yes.
What's the lowest number B you could get?
85. All right, so here we go. Let's talk about this. I'm not going to write out the definitions, but I will read them off to you. So let's talk about what an equal matrix is, or plural, matrices, right? So what are equal matrices? Well, it's probably what you would think, okay, if you had an equal matrix. So for instance, I'll just give you a chance to figure it out. What if I gave you a matrix? We'll make it really easy. 1, 2, 3, 4. And what if I said matrix B was an equal matrix of this? What would it be? Just the same dimensions? Yeah, it'd be everything. 1, 2, 3, 4 again. All right, so 1, 2, 3, 4. When all the elements match up. I'll read the definition. It says they have the same dimensions, all right? So it's a 2 by 2. The other one's going to be 2 by 2. And equal corresponding elements, okay, that are in the same position, all right? So just because this has a 1, 2, 3, and 4, they got to be in the same spot. So the 1 matches up with the 1, the 2, the 2, the 3, 3, 4, 4. That's pretty basic, wouldn't you think? It's pretty what? Elementary. Good. All right. So I could say that those matrices are equal to each other. So I could say A equals B, because A represents a matrix, capital B represents a matrix, and we say they're equal to each other, so these are equal matrices if they're exactly the same. If they're exactly the same, then they're equal. So in order to do this first example, you had to know about equal matrices. So here's example 1. And they're going to say find the values. We're just going to say find the variables, the missing variables. All right. So here's one matrix, and this is going to be A, 2B. This is going to be 3, 3D. Okay. There's one matrix, and it's equal to this matrix, 7, -8. C minus 5, that's one element, that's C minus 5, they're not two separate ones. And this is D plus 6, same thing, that's one element, it's not two separate ones. So they want you to find all the missing variables. All right, so I think it's pretty simple. Solve for A. What's A right off the bat without doing any math? It's 7, right, because A and 7 are in the top left, right? Oops, what did I just do? That's what I wanted to do. All right, so A is 7. Really simple. What about the B? How do I solve for B? Yep, 2B equals -8. Divide both sides by 2. What's B? -4. All right? Everybody got that part? Right? You're just setting the elements equal to each other. All right, and what's this? 3 equals C minus 5. Add a 5 to both sides. C is 8. Easy. And then do the D. 3D equals D plus 6. Subtract a D from both sides. You get 2D equals 6. Divide by 2. D is 3. And there you go. You found all the missing variables. Because you knew what? That these matrices were equal to each other. No biggie. Everybody's good with that, right? Yeah. Come on, Mr. Hamrick. It's got to get harder than this, right? Challenge me. Is that what you're saying? I thought I heard you say that. Okay. Now, let's talk about addition and subtraction, add and subtract of matrices. Again, this one, it's pretty much, what's the word? I had it in my head just a second ago. It's pretty, no, it is elementary, but it's when you can just look at this and kind of figure it out on your own. It's kind of self-explanatory. It's not exactly what I was looking for. There's a word. It'll pop in my head eventually. But shoot, I hate that. Forgetting words. Anyway, it doesn't matter. So what I'm going to do is I'm going to give you a couple matrices. I'm going to ask you to add them and subtract them. I'm not even going to give you any instructions. I bet anything that you could probably look at it and just come up with it. What's that? You don't think you could do it? Sure you could. This is really easy. Now, like I said, multiplication is not, okay? Finding the inverse isn't necessarily easy, but adding and subtracting is. And it's just like you would think it would be. I think you would feel that way. That's 1, -2, and 3. Okay, so this is the given. This is what they tell you. All right, here's what they want you to find. Okay, they want you to find, all right, and yeah, they just have you do two of them. So part A is just find A plus B. And then part B, what do you think they're going to ask you to do? Find what? A minus B. That's right. Okay, couldn't be any easier. So what do you think? I haven't even told you how to add these things together, but I bet you could figure it out on your own. If you want to go A plus B, that's right, you just add up the numbers. What do you think, though, is going to have to be true about both matrices before you add them together? They got to be, well, not equal. They don't, because they're not equal to each other in dimensions, right? They got to have the same dimensions, right? Okay, so you got to make sure that they have the same dimensions. If they don't have the same dimensions, you're not going to be able to add them, okay? So that's one little caveat to this. So make sure you know that. Tell you what, I'm just, in my notes, I actually put 2 plus 4, but I think we can do this in our head, don't you? All right, so what's the first one? 2 plus 4 is 6, and then let's go across the rows. So 7 and 2 is 9, and then what? -1, and then 4, and then -1 again, and then 8. And there you go. You've done it. You've added your first matrix. I told you it was pretty easy, right? What about A minus B? By the way, notice this, okay, because this is different with multiplication. Look at your final answer. It's the same dimensions as what you started with. Agreed? All right? Multiplication's different. All right? That's the next lesson, okay? But I'm just warning you. So what if you do A minus B? So what do we got? 2 minus 4 is -2. 7 minus 2, 5. 0 minus -1, minus negative, +1. Okay, 3 minus 1, 1 minus -2, it's +3. 5 minus 3, 2, and there you go. You've done your first subtraction.
I thought you were supposed to add up every in each box. 2, 7.
Just add up the ones that go together. Okay, so just add those together, right? Add the 7 and the 2. Add the 0 and the -1. The ones that are in the same spot, that are in the same location, all right, in the corresponding elements. That's what they use. That's the phrase that they use in here. Just add the corresponding elements, the ones that match up with each other. That's corresponding. Well, that was easy, right? Yeah. Let me just go through a couple things before we do the next problem. We are going to do multiplication today, but we're not going to multiply two matrices together. We're going to multiply a matrix by just a regular number, but we'll get that in a second. You might see this word in there. They might ask you, what is the additive inverse? Okay, let's just forget the matrix for a second. Let's just do a regular number. So what if I had the number 3? What is the additive inverse? I'll put an arrow. Yeah, the additive inverse just means you change the sign of it. That's all it means. So that would be -3. What's the additive inverse of -7? Just +7. Everybody with me on that? So that's additive inverse. No big deal. So they have an example, kind of an example. I don't think it's an official example, but they put it in here. 1, 0, -6, 9, -2, and 5. And here's what they do. They say, what is, find -c. That means the additive inverse, okay, when they put a negative in front of it. So what do you think we do to all these elements inside of here? Just change the sign of them. That's it. Super easy. What's 0? What do I change the sign of that to? Just 0. It doesn't. There's no sign. So this is a 6. That's a -9. That's a 2. That's a -5. Whoops. What happened there? -5. Super easy, right? That means additive inverse. Everybody got that? Yeah. No biggie. All right. I'm going to introduce a word to you that you may not have heard, but you're going to hear every once in a while in your math career. Okay, it's called a scalar. Okay, it's called a scalar. And basically a scalar is just a regular number. Okay, but in this case, it's a number that's being multiplied, in this situation, that's being multiplied to a matrix. So let's do this matrix, 2, -4, 0, 7. Okay, so there's my matrix. Now, this is multiplication. It's not the multiplication I keep talking about all the time, but it is multiplication, but there's just a number out in front. Let's put a 3 out in front of this. So again, I think it's kind of self-evident on how to do that. Still not the word I was thinking of, but it's getting closer. I know it's going to pop in my head one of these days. No, it's not. And you won't care. It's not that earth-shattering, but I don't know. It's just, it's in my head, and I just want to get it out of my mouth. All right, that's okay. So watch. If I told you to multiply 3 by this matrix, what would you do? That's it. Multiply every element by 3, and that's it. That's how you multiply a matrix by a scalar. The scalar is the 3. It's just a regular number, okay? We just give it a fancy name, call it a scalar, compared to a matrix. So you just multiply every element by 3. So what's this going to be? 6, -12, 0, 21. And that's how you multiply by a scalar. Again, not that big of a deal. Let's see, is this the last thing we do? No, we got a couple more things. All right. So here's an example. This is example 4, officially in the book. So here's what you're given. You're given this matrix, 4, 0, 2, 5. And you're given matrix B, which is 2, 4, 1, 3, 2, 4, 1, 3. Okay? And you got to find a few things. There's 3 things they ask you to find. They ask you to find 1/2 A. Then they ask you to find -5B. And they ask you to find 3A minus 2B. That's a 0 right there. All right. What does that A represent? Matrix A. Right, matrix A. So I just put a 1/2 and then show my steps, I guess. All right, and then you just do this. Then you multiply everything by 1/2. Simple. So 1/2 of 4 is 2, 1/2 of 0, 0, 1/2 of 2 is 1, 1/2 of 5 is 5 over 2. Let's not use decimals, just keep it as a fraction.
Why don't we use decimals?
Because we don't want to. All right? I mean, in real life, yes, you would absolutely use decimals if you're going to figure out lengths of stuff and all that kind of thing. But just for high school math, it's just a lot easier just writing 5 over 2. No reason putting 2.5, no reason putting 2.5. Just leave it 5 over 2. It's just easier that way. And everybody wants it easier, right? All right, so here we go. Let's do this one. So what's this going to be? That -5 out in front of what? 2, 4, 1, 3. All right, same thing. Just multiply by a scalar. What do we get? -10, -20, -5, -15. Piece of cake.
Is this how easy it goes?
No. Well, you might have some problems like this on here, but the whole thing's not. Tomorrow we're going to multiply matrices, and that's a little bit harder. Okay? I mean, it's not crazy hard. I keep talking about it like it's this crazy difficult thing. It's really not, but it's definitely more steps than what we're doing right here. Okay? Intuitive. That's the word I was thinking of. It's not as intuitive. You know what that means? You can just kind of think of it on your own, right? So these are intuitive. multiplication of two matrices is definitely not intuitive. You could sit here all week long and not come up with how to multiply matrices on your own. All right, but this stuff, you could have figured this out on your own.
Is the quiz going to be free?
I don't know what the quiz is going to be. I don't know. So don't ask about the quiz anymore. Don't worry about it. Just worry about what we're doing right here. So what do I have? 3a. Can we do a little bit of this in our head? Instead of writing the 3 in that A matrix, we can just look at this and multiply it by 3. So let's do that. What am I going to get? 12, and then 0, and then 6, and then 15. Is that all right? See what I did? I took matrix A, just multiplied everything by 3. But we're going to subtract 2b. So let's do that. Let's do it in our head. We can do this part in our head. So 2 times everything in here. So what's that going to give you? 4, 8, 2, and 6. Now we can subtract them. Again, it's pretty intuitive, right? You just subtract the elements. So 12 minus 4, that gives you 8. 0 minus 8 gives you negative 8. 6 minus 2 gives you 4. 15 minus 6 gives you 9. And there you go. And that's your answer. Circle it. We good? All right. Now, we're going to kind of put all that together to do a little algebra problem. So we're going to solve for x. Oh, brother. Oh, brother, where art thou? You ever hear that?
Nope. I did now.
It was a movie. It's the greatest soundtrack ever made in movie history.
Is that in your opinion or in general?
Oh, it's in general. Because it's my opinion.
What movie is it?
Oh, brother, where art thou? That's what the name of the movie is. It's not a Christian movie, no. I actually went to see that movie because I already had the soundtrack to it. And I knew like every song on the soundtrack. So when I went to see the movie, I was like singing along with it. Not out loud, but kind of like to myself in the theater. There's only like 3 people in the theater. That's how good the movie is. No, it was good. I mean, it's a well-known movie. All right. It's about stuff. All right. So here we go. So what we're going to do is we're going to solve for x. It says to solve. Solve for what? Well, there's only one variable here, and it's an x. And by the way, the x, I shouldn't make it so small. The x is a capital X. So what do you think the x represents? A matrix. Good. Okay? So what am I doing? I'm trying to find a matrix. If I multiply by 2 and then subtract it from this first one, I'm going to end up with this. Right? That's what they're asking you to do. So how do I do that? Well, just like you would do any math problem. Let's get this matrix. We want to get x by itself, right? So let's get rid of the matrix. Let's put it on the other side. How do I put it on the other side? I subtract it. That's right. Okay, I subtract this matrix. It's a positive out here, right? So I subtract the matrix from both sides. So what am I going to have? I got negative 2x equals, I'll just write it all out. I was going to copy and paste it, but 5, 2, 1, 4, 1. Keep that one first because that's already there. You're going to subtract this one from this one. Okay? So make sure that you do that. Oops. Minus. All right. 2, 1, 3, 3, 5, 1. Now, in this situation, I'm not going to divide by a negative 2 just yet. That'd be kind of ugly taking all this and dividing it by 2. Would you agree? So let's just do this step right now, and then we'll divide everything by 2. Yes? Good. So let's subtract. All right, pretty basic. Just kind of what we did. Pretty elementary, right? So 3 minus 2 is 1. 5 minus 1 is 4. 2 minus 3, negative 1. Down here, 1 minus 3, negative 2. 4 minus 5, negative 1. 1 minus 1, 0. All right, that's in a matrix. Whoops, I keep pushing this button on this pen. I wish I wouldn't. Okay, now, this is a little different. We really haven't done division And we don't really do division. Okay, what we're going to do, though, is we're not going to divide by a -2. We're going to multiply. Multiply by what? What will get rid of this -2 if I multiply it by? +2? +2 give me a -4. It's not going to get rid of it. A -1/2. That's right. I'm going to multiply by a -1/2. Dividing by 2 is the same thing as multiplying by 1/2, right? And why did I do that? Because I know how to multiply by a scalar. Okay? That's why I'm doing that. So I will do a little shortcut here. Okay? So x equals what? -1/2 in front of this. Agreed? And now what do I do? Just multiply this stuff by a scalar? That's easy. 1/2 of 1 is a half times a negative is just -1/2. -1/2 times 4 is -2. -1/2, that's a positive what? 1/2. Right here, positive what? 1. And then multiply that, 1/2. Multiply that, 0. There it is. That is your answer. Okay, that's what x is. Remember what I said to begin with? I said, what matrix times -2? I should say that. What matrix times 2, and then I subtract them is going to give me this right there. Well, this matrix will. Okay, it's not one that I would have just come up with off the top of my head, but I did some basic algebra stuff, and we're good to go. Shoot, I meant to. Let's do this. I thought I had this, and let me see if I did. I don't know. I might have. Let me just see something here. Go to Algebra 2 book screenshots. Yeah, that's the stuff from yesterday. Just let me do what I'm doing, okay? You ask me these off-the-cuff questions that don't have anything to do with math, and I'll tell you what. I'm just going to pop this on the screen. This is what, chapter 4? Okay. And let me scooch down. If anybody's watching this on YouTube, you're not going to see what I'm doing, but yeah, well, you can see right now what we're doing. Section 4.2. There we go. Section 4.2. I could probably do this pretty quick. When's this? 14? Is that what you told me? Okay. Oh, here we go. So I am going to do a little screenshot here. There we go. And I'm going to save it to downloads. And then now I'm ready to go back on here and go to downloads. I should have been prepared. Forgot about putting this on there. There you go. It didn't take too long. All right, so this is the problem that they give you in the book. Straight from the book. All right. So let's see what we're doing here. It says solid state drives, SSDs. They're just hard drives. Actually, I have a SSD drive in that computer right there. I put one in. I tell you what, if you have a computer that really is acting slow and it might be a little bit of an older computer and it's a desktop, if you got an SSD drive and you put it in there to run your programs and stuff, you'd have to reinstall Windows if you have Windows. But SSD drives are amazing, absolutely amazing. But anyway, enough of that. Let's do this. It says create matrices B and C, B for Boston, C for Chicago, representing the sales data from Boston and Chicago. So that should be pretty easy. So B is equal to, if you look at this this is the kind of hard drives they sell. That 120, what's the GB? What's that for computer nerds? Gigabytes, okay? So if you had a 120 gigabyte drive, a 256 gigabyte drive, in June they sold 78 of the 120s and 31 of the 256s, and same with July, okay? So you get the idea what's going on. So how do I make a matrix out of this? What do I use? Well, I can't write that in white because it's on top of white. So how would I write this? Just 78, what? 89, put 31 here and 19 here. All right, really easy. And then C, right for that. So it'd just be 102 and 97 and then 47 and 33. That's easy. So that's part A. Part B says add the matrices to obtain the total, okay, representing total sales. So if I added them together, we'll put T for total. And I already did it. It's 180. It's 186. It's 78. And it's 52. Where did I get those numbers? Did I just pull them out of the blue? No, I added what? 78 and 102. Okay, I added 89 and 97 to get 186 and so on. Everybody sees that, right? All right, and then the last part says create G, which is another matrix. Create G. Now this next little part might be a little tricky for you, but hopefully we'll explain it. Oh, you know what I got to do? I got to look at, yeah, right here. Look, it says the manufacturer wants to increase the total sales. This is my total sales right here, okay? He wants to increase them by 50%. That's what I'll put the G right here so I can see it. It's going to increase 50%. So how do I show? What math do I do to do a 50% increase? By 150? 1.5. Okay, it would be 1.5. Because if I multiply by 1, listen to me. Everybody listen. Shh. If it increased by 50%, that means we have our original 100%, right, plus 50% more. 50% as a decimal is 0.5, right? The 100 would be a 1.5. Does that make any sense? So when we increase it, we got to keep our original, which is 100% of what our total was. But if I went 50% more, I'm adding 0.5, right, to the original 100%. So what am I going to do right here? I'm going to multiply this by a 1.5. Our total. What was our total? It was the 180, the 186, the 78, and the 52. All right? And now you just multiply, use calculator, multiplying by 1.5. I've already done it, and it's 270, 279, 117, and 78. It's an example, so you could see something like that. Okay, this is the example straight from the book. All right, and that's your answer right there for G. All right, I don't know what G stands for. Your goal, representing the goal in total sales. All right, so if you increase by 50%, all right, that means you got what you got last year, right? So let's say last year, 2024, you had this, right? And then so 2025, you've got this, what you had last year, plus 50% more, right? That's your 1.5. So the 1 is what you had last year. The 0.5, it's half as much as what you got last year. But it's not just 0.5. If you just multiply by 0.5, you're actually getting half of what you got last year. You don't want half, you want to increase it, right? So it's half of last year's. This is last year's. This is half more than last year. Does that make sense? Okay, so sometimes that gets confusing. I don't know if I made it any better or worse, but that's how I explained it. All right, I think we finished everything. So that is it. I didn't put the lesson on there, but you have it on your lesson plans. What is it? 1 to 32 again, but I let you leave out some. 1 to 32. And omit. What does omit mean? Don't do it. So you don't have to do 21 to 26. Okay, omit. Just leave it out. All right? So you don't have 32 to do. You got whatever this is, 6 less than that? Everybody good? All right, that's it.